This is a lesson on balancing redox reactions. Balancing redox reactions. There are 9 steps. It sounds big, but it's not really that difficult once you get a pattern going and do it several times. First thing you do is split, and I'm going to write down all the steps first, and then we'll come back and do some reactions. Split into 2 separate half reactions. You find out what's being oxidized, and you put that on one line with an arrow in between, and then you find what's being, then that means everything else is being reduced, and you put that below that, and then you have a separate reaction that is being reduced. What we do is we split up these reactions, do the process, and then when we get done, we're going to combine them back together again. It's much easier than doing it any other way. The next step is balance all elements, all atoms, except oxygen and hydrogen. Leave those alone. Don't balance them. Just ignore them for now. The next step is balance oxygen. Now, oftentimes you're only going to have oxygen on one side. And if you have, like in the previous lesson, carbon dioxide going to carbon, there's no oxygen on the right-hand side. So what we're doing is this is an aqueous solution. So if it's an aqueous solution, we will have lots of water. Water will supply your oxygen. Next thing is, well, we balance everything, all the atoms except now for hydrogen, and you balance the hydrogen by adding. Now, we can't add water anymore because that'll throw the oxygen off. The only thing we can do is acid, or H+. So we add protons, or hydrogen ions, to both sides, or one side, or either side, depends on what you add. Okay, now, all matter is balanced, but the charges are not balanced. So you balance the charge by adding electrons. And you add electrons to the more positive side. If you add a positive and negative, that'll cancel it out. Now, you might not always get to 0, but if you have one side being +7 and one side being +2, you would need to add 5 electrons to the +7 side. Then you have +2, +2. So it doesn't have to be neutral 0, but they do have to be the same. You do all these steps separately, 2 through 5. They all are separate steps, separate from each other. Now you start the process of combining them. What you need is, since electrons cannot be destroyed nor produced, you have to balance the get a least common multiple of electrons and multiply everything on that side to get the least common multiple. This is sort of like, at this step, if you look at it, solving system of equations, and you try to cancel out something. You try to cancel out the x's or the y's. So it's kind of like along the same line. Now, cancel. You might cancel everything, or you might cancel some. You will always cancel all electrons. If you have water on one side, water on the other side, you might have 5 waters on the left and 2 waters on the right, so you cancel the 2. So you cut it down to the smallest number, So you cancel and combine. Sorry about the phone call. Cancel and combine to get one equation. A, check. All charges and all atoms should be the same on both sides. And then 9, if basic. If it's not an acidic solution, they'll tell you in the problem whether it's acidic or basic, or just assume it's acidic. If they tell you it's basic, what you do is you add hydroxides to cancel the hydrogen ions. Now you gotta add since it's balanced. If you add 7 hydroxides on the left, you gotta add 7 hydroxides on the right. And when you and then rewrite. So oftentimes when you do this step, you're going to have, say, 2 H pluses on this side, and over here you're going to have 7 waters. Well, it's not basic, and there's other things in there. We're just doing the step 9. Now, if you have to add 2 OHs to both sides. Now, on this side, you have 2 OHs, or 2 hydroxides, and 7 waters. Over here, 2 H pluses plus 2 OHs makes 2 waters, H plus OH. So that means you don't have 7 anymore, you have 5. So originally it was 2 H plus and stuff yields 7 H2O. In the end, you're going to have no H pluses on that side and 2 OH minus plus 5 H2O. Usually the H2O is going to be on the other side, but that's how that works. So you have the stuff, the reactants, all the other atoms there, and then that side there. Caution, it's not 20 H minuses, 2 OH minuses. You might want to make sure you work on that separating space that's out there. We do have a couple of samples, and we're going to do plenty more in class. Our first example is Mn manganate plus iron 2 reacts to form iron 3 plus Mn 2 plus. Okay. Here, what we're looking at is the iron. That's easy to find out what's changing. Iron is going from Fe2 plus to Fe3 plus. The manganese and everything else, if you ignore the irons, then everything else goes down below. If there were some other things in there, sometimes there might be 2, sometimes there might be 4, whatever it is. Okay, so step 1 is done. Step 2, balance all atoms except the oxygen and the hydrogen. 1 iron, 1 manganese, that's done. 3, balance the oxygens by adding water. Well, at the top, there's no oxygen, so you don't have to worry about that. Down here, you have 4 oxygens, so you need to add 4 waters to the other side. Now you have 4 oxygens and 4 oxygens, so step 3 is done. Step 4, balance the hydrogens by adding H+. Well, again, the top has no hydrogens on it. On the bottom, you have 8 hydrogens on the right, so you need to add 8 hydrogen ions on the left. That is done. Step 5, balance the charge by adding electrons. Well, this side on the iron is 2 plus, this side is 3 plus. What's bigger, 2 or 3? 3. By how much? 1. So you need to add 1 electron to the right-hand side on the top. Down here, you need to make sure you add all the charges possible and combine them together. So you have 8, take away 1 is 7, 2 plus 0 is 2. 7 is bigger than 2. By how much? 5. So you need to add 5 electrons to this side. When you do this, you will always have, as another check, an electron on the right, an electron on the left. It might be on the top or the bottom, but you're always going to have electrons on opposite sides. Otherwise, it's not a redox reaction. You have to produce and consume electrons. Electrons have to be transferred. So now we have to do the least common multiple of electrons. 5 electrons, 1 electron, least common multiple is 5. The bottom one's done already. The top one, you need to multiply everything by 5. Now the electrons are same on both sides. Charges are equal. Cancel and combine. Electrons will always cancel. You should not have any electrons floating around at any time. Looking around, there's nothing else that can cancel, so now we combine 8H plus MnO4 minus plus 5 Fe2 plus 5 Fe3 plus Mn2 plus 4H2O. The order that you write them on one side, the order that you write them does not matter. You could have the iron in the middle or iron at the end, iron 3 plus on the middle or the end. It doesn't matter where, as long as you put them all down. That makes these things great fun. A more complicated problem. This is a moderate problem right there. More complicated problem, you have iodate reacting with iodine to produce iron iodide, I think is what the name of it is, the I3 minus ion, in a basic solution. Well, first thing you notice is there is only one thing on the right-hand side. Well, you got to use it for both things. So the I minus, when you split these up into half reactions, goes to make I3 minus. The IO3 goes to make the I3 minus again. Sometimes that happens. Sometimes there'll be one thing on the left and you got to split it up. So, split them apart and combine. So that's step 1. Step 2, balance all atoms except for hydrogen and oxygen. This side needs 3 I minuses, and this side needs 3 IO3 minuses to do the triiodide ion. That's what it is, triiodide. So we're all good there. Balance the oxygen by adding water. Again, the bottom equation has the water in it, only the oxygen. So you got to add 9 H2O because 3 times 3 is 9. Top has no oxygen. Balance the hydrogens. There are now 18 H pluses. Top, no hydrogens. Balance the charge by adding electrons. This side has 3 minus. This side is 1 minus. What's bigger? The 1 minus. By how much? 2. So you need to add 2 electrons here. And on the bottom, you have 15 H pluses there and 1 minus here. And 15 plus charges. So the left-hand side is bigger by 16 electrons. That should be 2 electrons there. Now you got to get the least common multiple. Sometimes you got to multiply both top and bottom. If this was a 3, you'd have to multiply number would be to get that. So you have to do that. The bottom is 16, the top is 16, so you need to multiply everything here by 8. So 3 times 8 is 24 times 8, and 2 times 8 is 16. Cancel if you have to, electrons always. Now you can't cancel the I3 minuses because they're on the same side. They have to be on opposite sides, so that's the only thing that will cancel. Rewrite it. 18H plus 24I minus plus 3IO3 minus yields 9I3 minus plus 9 H2Os. We're not done yet. It's supposed to be a basic solution. So you need to add 18 H pluses, or 18 OH minuses to both sides. That makes 18 waters over here. 9 waters, so 9 will cancel with 9 of the 18. And that's usually what happens. You're going to cut the waters down by half and put it on the other side. So usually that's what happens when you switch those around. So now you have, in a basic solution, 9H2O plus 24I minus plus 3IO3 minus yields 9I3 minus plus 18OH minus. And this is kind of complicated, so let's go ahead and try to figure out how many we got here. 24, let's go with 18 H's, 18 H's, 9 O's plus 9 O's is 18 O's. That gives you 18 O's on the right. 24 plus 3 is 27 I's. 9 times 3 is 27 I's. Got the I's and the O's canceled. That's good. The net charge over here on the left side is 24 plus 3 is 27 minus 9 plus 18 is 27 minus. So it works. That ends this lesson on balancing redox reactions.